So as I already said that there are multiple scheduling algorithms, and now we will start seeing those scheduling algorithms. For each of these scheduling algorithms we will be seeing some in detail examples. Let's start with the first come first serve. So as we all know that whenever we are saying anything regarding first come first serve, queue comes into the play. Okay, what happens is your operating system will maintain a queue. Whenever a process is coming, whenever a process is coming in your ready state, that process is getting appended into this queue. Okay, first maybe first maybe P1, then P2, then P3, then P4, something like this. Okay, your CPU will come. Okay, your CPU will come, and your CPU will take the first process P1, will execute this process P1, and then move to this process P2. Then CPU will completely execute this process P2 and move to this process P3. Okay, so all the ready processes in the ready state, that where we can find all these ready processes in the ready queue. Okay, so this is a mode. Mode is non-preemptive. So what it says is, it says this first come first serve, this example or this algorithm follows non-preemptive modes. Okay, in preemptive modes also there are multiple scheduling algorithm. We will be seeing all of those. Just keep on watching the videos. Okay, fine. So this is the mode that I already explained, that is non-preemptive schedule. Okay, fine. Now what happens is the process comes into this arrival state. Okay, the process arrives. So once the process is scheduled at the CPU, it keeps on running. This is this non-preemptive schedule's nature. The process keeps on running. When the process is done with the execution, then the process is pushed into this terminate state. All right, fine. So now let's start with this given example. Okay, so these are the processes, these are the burst times of every process. Okay, and this is the arrival time of every process. So this arrival time is a relative time with your CPU start time. Okay, so when your arrival time is 0, it means your CPU started at 0 and your process came at 0. Okay, so the moment your CPU started, this process has arrived. 1 means, let's say your CPU started at 0, okay, and this process has arrived at 1. 2 means your CPU has started at 0 and this process has come at 2, something like this. Okay, so this arrival time, let's say the assumption is this arrival time is sorted. Okay, and if it is not sorted, then sort it out. Fine. So this is the conflict resolution. So let's say two processes are there with the same arrival time. Then how will you be choosing the right process? By seeing the lower process ID. Let's say arrival time is 0. For process number 2 as well, if the arrival time was 0, then which process would you have chosen? Process number 1. Because this process is having low process number. Okay, low process ID. Okay. So let's move to the next part. Okay, so this is something called Gantt chart. This is something called Gantt chart. Okay, I will be explaining this Gantt chart now. Let's say from the above example, I have copied this process number, arrival time, and burst time. These three columns I have copied. Okay, let me clean this and we will be filling this together. Okay, let's clean it. One second. All these are cleaned. Okay, fine. So this is first come first serve. So this is the Gantt chart. So at time 0, your process P1 has arrived. Okay, in the queue is process P1 is pushed. Okay, now your CPU comes and says, okay, let me see the queue. Process sees, your operating system sees process P1 is present in the queue. So what your operating system does, okay, let me clean this part as well. So what your operating system does, your operating system takes this process P1, schedule this at time 0. So what is the burst time? 5. So that is why this process is spanning to 0 to 5. So by the time t equal to 5 has come, process 2, process 3, process 4, all of them are pushed into the queue. Okay, now your operating system sees, oh, now P2 is there, so operating system will be scheduling this P2 now. Okay, P2, so P2 has burst time 3, so from 5, t equal to 5, P2 is scheduled, P2 will be running till t equal to 8, then P2 is also done. Okay, now your operating system sees P3 is in the queue, so P3 is scheduled now. P3's burst time is what? How much? 8 units. So 8 plus 8 is 16. Then also this is popped out. Then your operating system sees in the queue that P4 process is there. So take this P4 and schedule this P4 here. So what is the burst time? 6. 6 plus 6, 22. So it means, so if you see the Gantt chart, you will be seeing every detail. So what is the completion time of process P1? When this process P1 is completed at time t equal to 5, all right. When this process 2 is completed at 8, when this process 3 is completed at 16, when this process 4 is completed, that is completion time we are filling, right? So when this process P4 is finished at 22. So turnaround time, do you remember that I already told you there is a formula. Turnaround time is equal to completion time minus arrival time. So it says the total amount of the time this process was present inside our system. So if I make completion time minus arrival time, so this will be 5 minus 0 is 0, 8 minus 1 is 7, okay? 16 minus 2 is how much? 14. 22 minus 3 is how much? How much? 19. So turnaround time is also done. So completion time minus arrival time. 5 minus 0, 5, 8 minus 1, 7, 14, 8 minus 1, 7, 16 minus 2, 14, 22 minus 3 is 19. So now comes wait time. Do you remember one more formula that I told you? Turnaround time is a time during that time your process was inside our system. So this turnaround time will be spanning over burst time, that is CPU time, plus wait time. So how will we be getting this wait time? So wait time will be turnaround time minus burst time, right? Now we have turnaround time. Let's calculate the wait time as well. So turnaround time is this. Okay, let me change the color. Turnaround time is this, and this is the burst time. Okay. So let me fill this wait time. So wait time is 0. 5 minus 5, then 7 minus 3 is how much? 4. Then 14 minus 8 is how much? 6, right? Then 19 minus 6, that is 13. So these are the waiting time of each of the processes. Okay. Now let's calculate the response time. So what is response time? So the time duration between the process arrived in your ready state and the process is scheduled for the first time. Okay. This gap is called response time. So when this process P1 arrived at time t equal to 0, when this P1 is scheduled for the first time at time t equal to 0, what is the gap? 0 unit of time. What happened? What is the time? 0 unit of time. Then comes to process P2. So when this process came into a system at time t equal to 1, when this process P2 got scheduled for the first time at t equal to 5, so 5 minus 1 is 4, alright. Then process P3 comes, okay. Now what happens when it arrives at t equal to 2, when this P3 is scheduled for the first time, that is t equal to 8, so 8 minus 2 is 6, alright. Now process P4 has come, okay. When it has come at time t equal to 3, and when this process P4 is scheduled for the first time, that is 16, what is the gap? 13, all right. So now this is the formula that I told you, okay. Wait time is turnaround time minus burst time. So the assumption is in this example there was no dedicated IO time. So if there is any dedicated IO time, that will be mentioned in the question itself. And how do we solve those problems, we will be seeing in one of the future examples. As of now, just consider there is no IO, okay. So if you see this example, in this example, this wait time and response time, these two columns are same for all the processes. Okay. So why is that? Because this is non-preemptive schedule. Okay. Once you learn some preemptive schedules, then you will be able to understand this in much more better way. Now let me try with some example. Let's say this is the time when a process arrived. Okay, arrival time. Now let's say till this point the process is waiting for the CPU. Okay, let's say this is CPU or burst time. All right. Given that this is non-preemptive schedule, once a process starts execution, this will be taken from the CPU only at the termination phase. That means once it is scheduled in a single go, the process will be executed totally, and here the process will terminate. This is the completion time. All right. So if you see this duration, your process is waiting for the CPU. So this is wait time. And if you see the response time, what is response time? The time duration between the process arrival and the time when the process gets CPU for the very first time. That duration is called response time. So this duration is called response. I mean, this duration is response time as well. So this same duration is wait time, same duration is response time for this example. So that is why this wait time and response time, these two columns are same in this example. Going forward, once I discuss some preemptive schedules, you will be able to understand this point in much more better way. So if I go there, okay. So now from this chart, what you can find the average turnaround time, that is summation of all the turnaround times divided by number of processes. Then average waiting time, average response time, okay, average completion time, everything you can find. All right. So generally for all the operating system, they try to reduce this average turnaround time or average wait time or average this response time. These are main purpose of CPU scheduling. All right. So there might be multiple questions from here. So calculating this table and calculating this Gantt chart is a main deal here. Okay. Once you can successfully calculate this table and you can successfully calculate this Gantt chart, no matter what the question is, it will be very much cakewalk for you. Okay.